Hi, Jim Shaw here from Crystal Group. Wanted to spend a moment talking about MIL-STD-810, and we're talking about MIL-STD-810G in this case. Other customers may specify any different revision, but we just happen to be talking about G at this point, and wanted to talk for a bit about temperature shock and what that test is, and that's method 503. What this test is supposed to do is simulate the transition of your equipment from, say, a hot environment to a cold environment very rapidly. And the test defines high-speed transition as essentially 10 degrees C per minute, although some, that's at the very least 10 degrees C per minute. So you can actually have much more rapid transition in some of these testing. So what is it that you're really looking for when you take your equipment, say, out of a Humvee that's heated and put it into a very cold environment, or out of a air-conditioned room and putting it into a very hot environment? And so it's really kind of tailored. The testing is tailored around your specific application needs. And so what is it that you're looking for when you're doing this kind of testing? So you're looking for these are essentially surface types of tests. So you're looking at things that are more on the outside of the units. You're looking for shattered glass, or thermal coefficient of expansion changes that deform materials, crack materials, damage insulators, or alter the performance of the electrical system. And in the computer industry, that's essentially where we're looking at what's happening in the circuit board components, what things are being damaged by very, very rapid types of transition, so in temperature. So this testing for us is really about being able to take the unit out of one thermal chamber that's maybe down very low and put it into another thermal chamber that's very hot, and then basically go through that cycle of testing. The test is centered around essentially 4 different procedures. There's 1A through 1D. 1A is essentially a half cycle, so you just go, say, from cold to hot. B is a full cycle, so you go hot to cold and then cold to hot again, or vice versa. And then C is really multiple cycles, so the spec recommends at least 3, but you can do more than that. So in cycle D, the testing is done really to more extreme levels, but it's again multiple shocks. And so what you're trying to do again is simulate rapid temperature changes, whether that's taking a piece of equipment and throwing it out of a C-141 and you're doing an airdrop, or you're taking out of an air-conditioned facility into a desert environment. So you're looking for, can the equipment withstand that kind of abuse, and you're looking for any changes to the performance, any damage to the equipment, any damage, especially to those outer surface areas that are most easily impacted by thermal changes, because those are the ones that are exposed to the most rapid change. A couple of things that you want to make sure that you specify during this testing is the test temperature, the transition duration, and how long that you want to have the system at that temperature, or the dwell time, and then the number of cycles. Transfer times in terms of like door open, door closed kind of a thing, and then how often are you going to actually check the performance of the unit. And just like every other test in MIL-STD-810, this is intended to be highly tailored for the application that you're testing the unit for. So it is very specific to the application. So customers need to put some thought into what it is that I want to test in this method 503.
Join us next time for another shiny object at Crystal Group.